Hello, in this video, we will conduct a test to compare the performance of sets and lists. So we're going to write this program here is to create a set. So we're going to have the number of elements. This is 10,000. So we're going to have to popularize the list using this numbers here. So this is the sequence of numbers and do a random shuffle. And now we also have this set here. This is the same number and using the set. So this is the list and this is the set. And now we're going to do a test here, start time, and this is going to be the end time. So we'll get the end time, start time. So what we do is just look at this I in the, so for every element here in this range, and we're going to see if this I in S, so that's for the set. So we get a time now. And now start time, new start time, and this is doing the test for I in the list. And we get a time now for this, for all the numbers. Now we perform this to test if the element is in the list, and here first in the set. And now we do remove. So for every element here, we're going to perform this remove and get a time. This is in the set. And now same thing for the list, do remove. So this is the time. You see this is a test for the 10,000 elements in the set. The runtime is 1 millisecond. To test if 10,000 elements are in the list, the runtime is much higher, is 1057 milliseconds. To remove 10,000 elements from the set, it takes only 1 millisecond. To remove 10,000 elements from the list, it takes 464 milliseconds. So from this test, you can see that list is very efficient. In fact, you will see it in the next chapter when we introduce big O notation. You're going to see that for this set, all these operations, search, insertion, and deletion, it's order one, that is constant time. So it doesn't matter how big the list is, so that's the time. For the list, it's going to be all these operations for search, insertion, and delete. It's order of n times. So n, it's the size of the list. It's a linear time. If you increase the size, double it, and the time is doubled. So that is the difference between the two data structures. Sets are very efficient. Sets, if you don't care about the order of the elements. So in the set, there's no notion of index. In the list, you do have it. You can say, I'm going to get 100th element. And so that's from a list. For the set, also the elements are not duplicated. So they're all distinct. And in the list, you can have duplicate elements. That is all for this section on comparing the performance of sets and lists. See you on the next video.